All right, trig homework 2 starts off with multiplying involving binomials and trinomials in two variables. Some may have two terms, some may have three terms. Same kind of thing as we did when we did our foiling. I'm going to start out by taking the 3v times each of those two terms. So 3v times 4v would be 12v squared. Then I'm going to take the 3v times the minus y, so minus 3vy. Doing my middle term, 3y times 4v would be positive 12, and I'm going to write that as vy. 3y times a minus y would be minus 3y squared. And then I'm going to do my last term, which is the negative 4. Negative 4 times 4v would be negative 16v. Negative 4 times a negative y is a positive 4y. Then I'm going to go ahead and combine my terms. Now when they put the answer in, they're going to put it in descending order. Not that it really makes a difference, but they'll start with the highest exponents first. So they've got the 12v squared and the minus 3y squared. Then they're going to do the one with two variables, which is still second degree. Negative 3vy plus 12vy would be 9vy, combining my like terms. And then they're going to do the ones with one variable, so minus 16v plus 4y. And if there was a constant term, they put that on the end. And so all of that is going to go in for my answer. Now if you put them in a different order, that's perfectly fine. We have the commutative property, but that's the order you're going to see those in. Now I use different colored markers to keep myself organized. Another method of keeping yourself organized is to use boxes. And you don't have to do this, but just for those who maybe are getting lost in all of their multiplying, it's a good little trick. And so what I do, since I have a 2 by a 3, I'm going to make a 2 by 3 set of boxes. 2u plus 7 is my binomial. 5u minus 3y minus 2 is my trinomial, and then I'm going to multiply it out. 2u times 5u is 10u to the second. 2u times negative 3y would be negative 6uy. 2u times negative 2, negative 4u. 7 times 5u, 35u. 7 times negative 3y, negative 21y. 7 times negative 2 minus 14. Now I have everything in boxes, so if I get interrupted in the middle of the problem, I know where I left off, and I can go ahead and write down my answer. I've got the 10u squared. I've got a minus 6uy. Here I've got some like terms. 35 minus 4 would be positive 31u. Smush that in there. Minus 21y, and minus 14. And all of that would go in for my answer. So number 3, we're multiplying that one out. 3y times 7y is 21y squared. 3y times negative 5w is negative 15. I'm going to call that wy. You can call it yw if you choose. Negative w times 7y, negative 7y, whoops, so better be consistent, negative 7wy, negative w times negative 5w would be positive 5w squared. Negative 7 times 7y would be negative 49y, and then negative 7 times negative 5w, positive 35w. So here, that pairs my like terms. In descending order, 21y squared plus 5w squared. Negative 5 minus 7 would be negative 22wy minus 49y plus 35w then would be my answer. 4, 5, and 6, factoring out a monomial from a polynomial univariate. When it says to factor, we're trying to figure out what times what would have given me this answer. So basically, I'm dividing this out. So I'm looking for my greatest common factor. Greatest common factor of 12 and 16 would be 4. And then when I look at my variables, I can only take out the lower amount that I have. So if I have a u and a u to the 5th, I'm going to do the u. I have an x to the 4th and an x to the 9th. I can take out x to the 4th. And this has a y squared, but that doesn't have any y's, so I can't take out any y's because it's not common to both. So I put my greatest common factor out in front, and then basically I just divide it out of both terms. I'm dividing my coefficients, the numbers in front. I'm going to subtract my exponents. So 12 divided by 4 is 3. I had 1 and took out 1. I don't have any left. I had 4 and took out 4. I don't have any left. And then I have my y squared. So that if I took 4ux to the 4th times 3y squared, I get 12ux to the 4th y squared. Plus 16 divided by 4 is 4. I had u to the 5th. I took out a u, so I have u to the 4th. I had x to the 9th. I took out x to the 4th, so I have x to the 5th. And so if I took 4ux to the 4th times 4u to the 4th x to the 5th, I would get the 16u to the 5th x to the 9th. The next one then, if I'm going to factor that one, I'm looking for my greatest common factor. I have 5 and 20, so I can divide those both by 5. U to the 9th and u squared, I can take out u squared. V to the 5th and v squared, I can take out v squared. So if I divide those out of both my terms, 5 divided by 5 is 1. I don't really need to write the 1 unless there's nothing else left. U to the 9th, if I take out u squared, I have u to the 7th. V to the 5th divided by v squared, I have v to the 3rd. Negative 20 divided by 5 would be minus 4. U squared divided by u squared would be 0 of them. V squared divided by v squared, 0 of those. But I still have that x to the 4th. So I have 5u squared v squared times u to the 7th, v to the 3rd, minus 4x to the 4th. And one more factoring there. I'm going to factor out my greatest common factor. In this case, both of these are divisible by 4. I can also take out a v squared, and I can take out a w to the 6th. So I'm left with 1 v to the 4th. The w's are going to be gone. Y to the 9th. And then I'm going to have negative 24 divided by 4 is negative 6. I took out the v squared. I had w to the 7th, and I took out 6 of them, so I have just a w left over. So 4v squared w to the 6th times v to the 4th y to the 9th minus 6w. The next three, 7, 8, and 9, are factoring by grouping. And when I factor by grouping, I can leave it in the same order, or I might want to rearrange it. I personally like to put it in descending order, so I like to start with the one with the highest exponent. In this case, I'm going to do the negative 3u squared, and I'm going to group it with the one that I think has the most in common with it. So in this case, I would use the negative 18u, because it has both a number and a variable in common. So out of those two, I want to take out my greatest common factor. Since they're both negative, I'm going to take out negative 3u for my greatest common factor. Negative 3u squared divided by negative 3u would leave me just the plain u. And negative 18u divided by negative 3u would leave me a positive 6. So again, if I took this times this, I get my first term. This times this, I get my second term. When I do my other two terms, I want to end up with the same thing in the parentheses. So I look at it and say, okay, I want the term with the u written down first because I have the u first in my parentheses. So I have a positive uy and a positive 6y. It doesn't have a plus sign there, but I know it's positive. What do those both have in common? They both have a positive y in common that I can take out. If I take the y out of each of those, you'll notice I'm left with u plus 6. So u plus 6 now becomes my common factor. So what I'm doing basically is factoring out my greatest common factor, which is the u plus 6. And when I factor that out, it leaves me another pair of factors, the negative 3u plus y. And so my answer, u plus 6 times negative 3u plus y. Now if you wanted to check that, what you would do is FOIL it out to make sure you get the same thing you started with, because that's what factoring is you're trying to figure out, well, what times what would give me those 4 terms. U times negative 3u is negative 3u squared. U times a positive y is a positive uy. 6 times negative 3u is negative 18u. 6 times y is a positive 6y. Notice I got the same 4 terms. They're just in a different order, but we have the commutative property, so we could rearrange those. So if you wanted to check your answer, just FOIL it back out and see if I get the terms I started with. So number 8 again says to factor by grouping. Again, I always like to start with the highest exponent first, so I'm going to use the negative 9y squared. I'm going to group that with the minus 36y because I think they have the most in common. You could try it with something else. If it doesn't work, you can always start over and guess again. But I'm going to hear both of those have what in common. In this case, I can divide them both by a negative 9 and by a y. So negative 9y is my common factor. If I divide negative 9y squared by negative 9y, I'm just left with a positive y. And negative 36y divided by negative 9, positive 4, right? Negative divided by a negative makes that positive. So my goal when I do my other ones, I want the one with the y first and the 4 second. So I have a positive yv and a positive 4v. They both have a positive v in common. If I take those v's out of there, I'm left with y plus 4, which is my goal, to end up with that exact same thing in both sets of parentheses. So my common factor here is the y plus 4. If I take that out of each of my terms, my other factor is going to be the negative 9y and the plus v that were out in front of each of those factors. And so y plus 4 times negative 9y plus v going to be my answer. And I'm going to sneak this one in here, see if I can get this all written in. Again, I'm going to start with the negative 4y squared. I'm going to group that with the positive 16y since it has both the number and the variable in common. Now in this case, do I want to take out 4y or negative 4y? Really doesn't matter. Either one should be okay, so you just pick. In this case, I'm going to decide I'm going to take out the negative 4y, just for fun. Whoops, negative 4y. Better write my y down. So, negative divided by a negative is going to leave me a positive y. Positive divided by a negative is going to leave me a minus 4. So I have y minus 4 when I factor out my negative 4y. So on my other ones, I want y and first. So the negative yu and the positive 4u. So again, you look at that and say, okay, do I want to take out a positive u or a negative u? Well, I look to see what I want to have in the parentheses. I want my y to be positive, so I need to take the negative out. So I'm going to take the negative u out of there. Negative divided by a negative leaves me a positive y. Positive divided by a negative leaves me a negative 4. So my common factor in this case is the y minus 4. My other factor is going to be negative 4y minus u. Now, had you decided to start with this being positive, your answer is going to look slightly different, but it's still going to be equivalent to what we have here. Number 10, 11, and 12, factoring a quadratic with a leading coefficient greater than 1. Quadratic expression just means it has that squared term. It's a second degree polynomial. And when we have a trinomial, one with 3 terms, usually it came from FOILing something out. So when I look at that, I say, oh, it has 3 terms, it's got that squared, so I probably can guess, oh, it came from FOILing. Now these ones I do differently, so if you want Linda's note sheets, you can go under the resources to A14 and print out the Word document that have the steps that I'm going to do the problem in. The LX problem or the LX program does it a little differently than I do it. So here's what I do. I start by factoring my first term. 10z squared could either be 1z times 10z or 5z times 2z. I really don't know which pair it is. I'm just going to do guessing and checking. And if one pair doesn't work, I'm going to try the other pair. Sometimes I'll even write down the 2 sets of parentheses and do both of them. So I'm going to try the 5z and the 2z. If that doesn't work, I've got to change it to the 1 and the 10 and try that. The next thing I do is figure out my signs. If my n sign is positive, both signs have to be the same as the middle. So they either have to be both pluses or both minuses. I look at my middle sign. Whatever the middle sign is, that's the sign I'm going to use. So in this case, since the end is positive, both signs are the same as the middle, a plus and a plus. If the end is negative, we've got one plus and one minus, because a positive times a negative is going to give me that negative on the end. Then I factor my n number. 18, 1 and 18, 2 and 9, 3 and 6. Those are all the factors of 18. I have to find the pair that when I do the outside product plus the inside product, it adds up to the 49 in the middle. Again, I really don't know which way to go. I'm just going to start from the bottom and work my way up. So I'm going to put the 3 and the 6 in and test it out. This is going to give me 30 plus 6. My outside product is 30z. My inside product is 6z. Well, 30 plus 6 is not 49. So then what I'm going to do is just switch them around. I'm going to put my 6 and then my 3. That's going to give me 15 plus 12. Well, again, if I do 15 plus 12, I'm not going to get 49. So then I go to the 2 and the 9. 2 and 9. That's going to give me 45 plus 4, and sure enough, 45 plus 4 gives me 49. So this is the pair of factors that I want. If I really wanted to double check, I would go ahead and FOIL that out. 5z times 2z is 10z squared. 5z times 9 is 45z. 2 times 2z is 4z. 2 times 9 is 18. My 45z plus my 4z adds up to the 49z. Almost can read that. Adds up to the 49z in the middle. So I know, yep, if I FOIL that out, I get what I started with. I've got my right pair of factors. So number 11, again, it tells me to factor. I've got a quadratic trinomial. It has the squared term and it has 3 terms. So good clue that it came from FOILing. Factoring my 12x squared could be 1x times 12x, or it could be 2x times 6x, or it could be 3x times 4x. So this one has a whole lot of choices. Again, I have no idea which pair it is. I like to start from the bottom and work my way up, just so I have an order to follow, but it's kind of just guessing and checking. So I'm going to put the 3x and the 4x. Looking at my signs, again, the end is positive, so I know both signs have to be the same as the middle. I'm going to have a negative and a negative. Fortunately, 15 doesn't have a whole lot of factors to check. 1 and 15 or 3 and 5 are the only pairs that it might possibly be. So I'm going to start. I'm going to put in the 3 and the 5. So I'm going to get negative 15 plus negative 12. Oh, negative 15 plus negative 12 is not quite there, right? I get negative 27. So I switch them around. I was close, but not quite. I'm going to put the 5 here and the 3 here. Well, that's going to give me negative 9 and a negative 20, which is negative 29. Not going to be 28, right? So I say, okay, what about the 1 and the 15? If I do the 1 and the 15, well, 3 times 15 is going to be way too big, right? Same thing if I put the 15 here, I'd have to take 15 times 4. I'm going to get 60. That's going to be way too big. So I've determined here that I don't think the 3x and the 4x are the pair that's going to work. So now I got to try a different pair. And so I'm going to try my 2x and my 6x and start repeating the process. So if I try the 3 and the 5, That's going to give me negative 10x. That's going to give me negative 18x. And sure enough, negative 10 plus negative 18 is negative 28. So I found the pair that works, 2x minus 3 times 6x minus 5. Again, if you wanted to, you could FOIL that out and check it. Number 12 again tells me to factor. I've got a 9y squared, so it might be a 1y times a 9y or 3y times 3y. So again, I have no idea. I'm just going to try the 3y and the 3y. If that doesn't work, I have to try the 1 and the 9. This time, the end is negative. If the end is negative, you've got one positive and one negative. You don't know which place they go. You're just going to guess and check. If you get the right middle number but the wrong sign in front of it, switch your signs around. Don't move your numbers, just switch your signs. 8. 1 times 8 or 2 times 4. So I'm going to just plug them in and guess and check. If I put my 2 and my 4, that is going to give me negative 12 plus 6. Not going to be big enough because I have to add up to negative 21. It's not going to make a difference if I switch them around and try 4 and 2 since I've got 3 and 3. So I'm going to do the 1 and the 8. So negative 24 plus 3. Hey, that looks good. Negative 24y plus 3y gives me negative 21y, which is what I want in the middle. So that's going to end up being my answer. 3y plus 1 times 3y minus 8. So a matter of guessing and checking when I've got that quadratic trinomial that I need to factor out. Factor the first term, figure out your signs, factor the last term, and then basically you're just guessing and checking till you find the pair that works. The next ones are factoring a difference of squares in one variable. The difference of squares is pretty easy to factor because we know it factors into conjugates. And so if you recognize that it's the difference of squares, difference means I'm subtracting and both of these are perfect squares, yes it is, then it's not too bad to factor. It does factor into your two binomials, so you have your two sets of parentheses, but basically you're doing the square root of each term. One will have a plus and one will have a minus. So 64 is 8 times 8. 81v squared is 9v times 9v. And one term will have a plus and one term will have a minus, so that when you FOIL it out, the middle term cancels out. So just for fun, if I'm checking this one, 8 times 8 is 64. My outside is negative 72v. My inside gives me positive 72v. And then the last 9v times negative 9v is negative 81v squared. You'll see that your middle terms become opposites. And that's how we end up with that difference of squares, by multiplying what they call conjugate. It's the same values with opposite signs in the middle. So again, if I recognize, oh yep, I have the difference of perfect squares, it tells me to factor. I'm going to start with my two sets of parentheses. 25z squared would be 5z times 5z. 4 is 2 times 2. I know that I have to have conjugates, one plus and one minus, so when I FOIL it out, the middle term cancels out. So number 15, if I'm going to factor that, again, if I recognize it's a difference of squares, I can just put my two sets of parentheses. 49, 7 times 7. 64, z squared would be 8z times 8z. And then again, I have to have one with the plus and one with the minus. So I get 7 plus 8z and 7 minus 8z. So factoring the difference of squares, fairly easy as long as you recognize that's what you have when you're factoring. Next ones tell you to factor a product of a quadratic trinomial and a monomial. You're not going to know what that is. You look at that and it has 3 terms, but it's not a squared one. So when I read it and the directions tell me factor completely, it tells me I want to factor out the greatest common factor first and then see if I can factor it a second time and maybe even a third time. So in this case, if I look for my greatest common factor, what can I divide all 3 of those terms by? 9, 24, and 12 are all divisible by 3. I have an x to the 5th, an x to the 4th, and an x to the 3rd. I can only do the lower one, so I'm going to take out 3x cubed from each of those terms. So 9x to the 5th divided by 3x cubed would be 3x to the 2nd. 24x to the 4th divided by 3x cubed, I'm going to get 24 divided by 3 is 8. Subtract my exponents, so 4 minus 3 leaves me just an x. And then 12x to the 3rd divided by 3x to the 3rd, 12 divided by 3 is 4, and then 3 take away 3 is 0 left over. So what I have left is now my quadratic expression that I had factored earlier. Sometimes this will factor, sometimes it won't. Sometimes that'll just be your answer and you're stuck. But you've got to check to see if you can factor again. Most of the time they're going to give you ones that factor again. So 3x squared would be 3x times x. My signs. The end is positive, both are the same as the middle, a plus and a plus. Factors of 4. It's either 1 and 4 or 2 and 2. I'm going to try the 2 and 2 first. That gives me 6x plus 2x, which is 8x, so that's the right factoring. I still have my 3x to the 3rd in front, and so my answer, 3x to the 3rd times 3x plus 2 times x plus 2. So number 17 again tells us to factor completely. When it says factor completely, that's my sign that says look for a greatest common factor. All of these are divisible by 3, and of my variables I can only take out a y. So I'm going to divide 3y out of each of those terms. 3 divided by 3 is 1, and I get y squared, so I don't need the 1 in front. 24 divided by 3 is 8. 2 minus 1 gives me y. And 48y divided by 3, 48 divided by 3, must be about 16, huh? Again, I've got this quadratic expression. I've got to see if I can factor again. So that factors into y and y. The end is a positive, so is the middle, so a plus and a plus. Factors of 16 that add up to 8. 4 times 4 is 16. Now notice that one factored into a perfect square, so they're going to want you to rewrite that as y plus 4 squared. If you don't, it's still going to say it's correct, however, and then the 3y is going to be in front. So I'm going to have 3y times y plus 4 squared. So if we look at number 18, 4, 18, and 10 are all divisible by 2. U to the 5th, u to the 4th, and u to the 3rd. I have to use the lower one, so 2u to the 3rd is what I'm going to take out of each of my terms. So 4u to the 5th divided by 2u to the 3rd would be 2u to the 2nd. Negative 18u to the 4th divided by 2u to the 3rd would be negative 9u. And negative 10u to the 3rd divided by 2u to the 3rd is just a minus 5 then. Again, we've got to try factoring our quadratic expression. 2u squared, 2u and u. The end is negative, so I know one's a plus and one's a minus. I don't know what order, I'm just going to guess. Factors of 5. 1 and 5 is the only way to factor 5. I want a minus 9. So if I check that out, negative 10u plus 1u, sure enough, is negative 9u. I've got the right factoring. And so 2u to the 3rd times 2u plus 1 times u minus 5 going to be my answer on that one. Now the next one again tells me to factor completely in the directions. The name of it is factoring with repeated use of difference of squares. So you'll see where that comes in, where I have the repeated use of the difference of squares formula. But again, it says factor completely, and whenever it says factor completely, there's my sign, take out the greatest common factor first. So in this case, I can divide both of those by 2, and they both also have a u squared. Can't take out any v's. So if I take the 2u squared out of there, 32u squared divided by 2u squared just leaves me a 16, minus 2u squared v to the 4th, going to leave me a minus v to the 4th. So what I have left in the parentheses is that difference of squares that we factored before, where we said, oh, it factors into conjugates. 16 is 4 times 4. V to the fourth would be v to the second times v to the second, and one has a plus and one has a minus. The 2u squared is going to go out in front. Now notice the directions or the name said with the repeated use of difference of squares formula. We have the difference of squares here, but we have it a second time. We can't factor the sum of squares. If we tried to factor that, there has to be a middle term because we'd be adding the two middle terms together. So we can't factor the sum of squares, but we have to factor the different squares a second time. So factoring the 4 minus v squared. Factors of 4, 2 and 2. Factors of v squared, v and v. One has a plus, one has a minus. And so I have 2u squared times 4 plus v squared times 2 plus v times 2 minus v. And all of that has to go in for my answer. It's a big long answer to type in. So number 20, same thing. Tells me to factor completely. Whenever it says factor completely, I look for the greatest common factor. Both of these have a v to the third power. So I'm going to put the v to the third out in front. Leaves me a u to the fourth and a minus 16. Again, looks very similar to the previous one. They just have it switched around. You don't want to switch it. Leave it in the order it is and just go ahead and factor. So factoring the u to the fourth minus 16. U to the fourth is u squared and u squared. 16 is 4 and 4. One's going to have a plus and one's going to have a minus. And of course the v cubed is out in front. We know we're factoring with the repeated use of difference of squares. You can see again we have the difference of squared on the end, so I'm going to factor that. Factors of u squared, u and u. Factors of 4, 2 and 2. One has a plus and one has a minus. So we have v to the third times u squared plus 4 times u plus 2 times u minus 2. And all of that is going to go in for your answer. I'm going to try to sneak the next one in so I don't have to move the board. Looking at that one, my greatest common factor, they both have an x to the third. So I'm going to take the x cubed out, and what I have is 81 minus u to the fourth. And so factoring that, I'm going to go over here. The x to the third is out in front. Factoring the 81 minus u to the fourth. 81, 9 times 9, u to the fourth. U squared and u squared, we know one has a plus and one has a minus. So again, we know that we can factor a second time. We can only factor the one with the minus sign, the difference of squares. So I'm going to have the x to the third, I'm going to have the 9 plus u squared, and then I'm going to factor the 9 minus u squared. So 9 would be 3 times 3. U squared is a u and a u. We know one has to have a plus and one has to have a minus. So we have x to the third, 9 plus u squared, 3 plus u, and 3 minus u. So you won't see the name when you're on the assessment, factoring with the repeated use of difference of squares. You'll just see factor completely. Know whenever it says factor completely to do the greatest common factor first. And then hopefully you recognize you have the difference of squares and then the difference of squares a second time. The next three are factoring the sum or difference of cubes. Again, this is one I would probably go to the resources, look for A18 and print out the formula. On Alex, they do have the formula, but they don't really explain the formula. And so here's what we do when we factor cubes. First thing we're going to do is we're going to do the cubed root of each of my terms. Same sign's going to go in the middle. So if I have my set of parentheses, the cubed root of 125 is 5, because 5 times 5 times 5 is 125. Cubed root of 8v cubed would be 2v. 2v times 2v times 2v is 8v to the third. Same sign in the middle, so there's going to be a minus sign in there. So we have 5 minus 2v. Now in our other set of parentheses, we're going to end up with 3 terms. The first and the last term will be the squares of each of these. 5 times 5 is 25. Negative 2v times another negative 2v would be a positive 4v squared. That end term will always be positive because you're squaring something. So I squared the 5, I squared the minus 2v. So that if I took 5 times 25, I get 125. If I take negative 2v times a positive 8v squared, I get negative 8v cubed. The middle term is what cancels out that stuff when you multiply it all out. The middle term is going to be the opposite of the product of these two things. So if I multiplied those together, I get negative 10v. The opposite of that is going to be a positive 10v. That's going to go in the middle. And so you're going to see a formula that sort of looks like that, but you're not really going to know what's happening there. Again, if you really wanted to check your answer, you could FOIL it out. 5 times 25 is 125. 5 times 10v is 50v. 5 times 4v squared is 20v squared. Negative 2v times 25 is a minus 50v. Those cancel. Negative 2v times 10v is minus 20v squared. Those two cancel. Negative 2v times 4v squared minus 8v to the third. So you can see when you multiply it out, those middle terms end up canceling each other out. So 23, I'm factoring the sum of cubes. Notice that with cubes, it doesn't matter if it's a sum or difference. With squares, we can only do the difference, but cubes, we can also do the sum. Factoring that, my first set of parentheses. Cubed root of 27u cubed, 3u. Cubed root of 125, again, is 5. Same sign in the middle, so this time we're going to have a plus sign in the middle. Second set of parentheses. The first and the last, we're going to square each of those. So squaring that, 3u times 3u, 9u to the second. Squaring 5, positive 25. So 3u times 9u is 27u to the third. 5 times 25 is 125. Middle term cancels stuff out. I multiply this together, which is 15u. I do the opposite. So minus 15u is what goes in the middle of my expression. So 3u plus 5 times 9u squared minus 15u plus 25. Number 24, same kind of thing. I'm factoring the difference of perfect cubes. In my first set of parentheses, I do my cubed roots. The cubed root of 8y cubed is 2y. Cubed root of 27 is 3. Same sign in the middle, so there's going to be a minus sign in there, 2y minus 3. Second set of parentheses. Squaring each of those two terms. 2y times 2y, 4y squared. Negative 3 times negative 3, positive 9. 2y times 4y squared is 8y cubed. Negative 3 times a positive 9 is a minus 27. My middle term, the opposite of this product. This product is a minus 6y. So in here, we're going to have a positive 6y. And so 2y minus 3 times 4y squared plus 6y plus 9 going to be my answer. All right, 25, 26, and 27 are simplifying the ratio of polynomials. If I want to simplify the ratio of polynomials, what I have to do is I have to put it in factored form. So I want to factor out the top and the bottom. When I'm looking for factoring, the first thing I want to factor out is a greatest common factor if there is one. In this case, I can factor 6 out of both of those. So I would take out the 6. 96 divided by 6 is 16. So I'm going to have 16 minus u squared. Then I'm going to look to see what's left in the parentheses. Can I factor that again? If I look at this one, this is the difference of perfect squares, so I can factor that with my two sets of parentheses. Factors of 16, 4 and 4. Factors of u squared, u and u. One will have a plus and one will have a minus since we have the difference of perfect squares. When I look at the bottom of that expression, there is not a greatest common factor. There's nothing I can divide out of all three terms, so I just go to my regular factoring. I know that FOILs out factors of u squared, u and u. My signs, a plus and a minus. I want the factors of 20 that give me a plus 1 in the middle. 5 times 4 is 20. Since I want a plus 1, I need a plus 5 and a minus 4. Now in this case, I look at it and say, well, I don't have anything that's exactly the same, but if I could switch this one around to 4 minus u instead of u minus, or 4, if I could switch it around to u minus 4 instead of 4 minus u, then they would be the same. So all I'm going to do here is factor out a negative 1. When I factor out a negative 1, it's going to make that a negative 6 instead of a positive 6, and make this u minus 4, basically just switching both of those signs. Now I can go ahead and cancel that out. So those will cancel. I have negative 6 times 4 plus u over u plus 5 for my answer. You may see on Alex where they might put the negative in front. It shouldn't make any difference, but they might put the negative in front of your fraction instead of in front of the 6. So if you need to flip one of those around, you just factor out the negative. Now if it was the plus 1, we have the commutative property. You can just switch the plus 1, but if it's the minus 1 you need to switch around, you need to factor out that negative 1. So 26, same kind of thing. If I look at that, I want to simplify it, so I want to put it in factored form. Looking at the top, I want to take out my greatest common factor. I can either take out the negative 5 or a positive 5. It's kind of up to you, but since I want my x squared to be positive, I'm going to go ahead and take the negative 5 out. So if I take the negative 5 out, it leaves me a positive x squared, and then a positive 5 divided by negative 5 would be minus 1. Again, in that set of parentheses, we end up with the difference of perfect squares that we can factor. So we're going to go ahead and factor that. That factors into x plus 1 and x minus 1. Factors of x squared, x and x, factors of 1, 1 and 1. We have to have a plus and a minus. Bottom of that expression does not have a greatest common factor, so we just go ahead to factoring it out by foiling. Factors of x squared, x and x. The end is negative, so we know we have a plus and a minus. Factors of 5, we want a positive 4, so we have to have a plus 5 and a minus 1. In this case, our x minus 1s are both the same. We can go ahead and cancel those out. So we're going to have negative 5 times x plus 1 over x plus 5. And again, that negative could be out in front of your fraction, or if you want, you can leave it up there with the 5. It shouldn't make any difference. 27 then, if I want to simplify that one, if I look at the top, there isn't a greatest common factor. I'm just going to go ahead and go to my foiling. So x and x. The end is positive, so both signs are the same as the middle, a negative and a negative. Factors of 6 that add up to 7, well, 1 and 6. On the bottom here, you have 72 minus 2x squared. Again, you can either factor out a 2 or a negative 2, but since I realize that I want to have my x's first when I factor, I want to switch that around. So the more practice you get at this, you'll say, oh, I probably should take the negative out instead of the positive so that I can flip that expression around. If I take the negative 2 out of there, I'm going to get negative 36 plus x squared, which in other words would be negative 2 times x squared minus 36. Right? 72 divided by negative 2 is negative 36. Negative 2x squared divided by a negative 2 makes it a positive x squared. Now I can factor that, and it'll be in the same order as my top expressions with the x's first. Difference of perfect squares again, x and x, 6 and 6, a plus and a minus. So that you can see there, oh, now I've got the x minus 6 in the same order. I don't have to worry about factoring out my negative sign. So my answer, I'm going to write it here in blue. We're going to have x minus 1 on top. We have negative 2 times x plus 6. Again, they'll probably put the negative in front instead of in front of the 2. Really shouldn't make any difference, but my answer should look something sort of like that. So the last one's here on homework day 2, dividing rational expressions involving quadratics with a leading coefficient of 1. I'm dividing two expressions, and when I divide expressions, I have to invert and multiply. So I change this problem to x squared minus 1 over x squared plus x minus 6 times the reciprocal 3x plus 9 over x minus 1. Again, when we're multiplying fractions, we can cancel out the common factors, which tells me I want to factor this out first. So factoring the top of that, I'm going to have x plus 1 and x minus 1 because I can see that's the difference of perfect squares. On the bottom, I'm going to factor that. X and x, since the end is a negative, a plus and a minus. Factors of 6, I want a positive 1, so I need a plus 3 and a minus 2. 3 minus 2 is plus 1. The top of that next fraction, I have a greatest common factor of 3. If I divide both those terms by 3, I get x plus 3. Bottom, it's not a squared one. It doesn't have a greatest common factor, so I just have to leave it as x minus 1. So I'm just going to go ahead and cancel out my common factors as long as one is on the top and one is on the bottom. I can cancel out the x minus 1s. I can cancel out the x plus 3s. So on top, I'm going to have 3 times x plus 1. And on the bottom, I just have the x minus 2. Now I could have put the 3 behind the x plus 1. It just looks prettier in front. And so that's where I left that. Number 29, same kind of thing. I'm dividing fractions. I know that when I divide fractions, I have to invert and multiply. So x squared minus 4 over 4x plus 4 times the reciprocal x plus 1 over x squared plus x minus 2. Then I'm going to go ahead and do my factoring. Again, this is the difference of perfect squares. X and x, 2 and 2, x plus 2 and x minus 2 is how that's going to factor out. On the bottom, it's not a squared one. I look for my greatest common factor, which is 4. So if I divide those both by 4, I get 4 times x plus 1. Remember, 4 divided by 4, I can't just say it cancels. There's a 1 there. 4 divided by 4 is 1. The x plus 1 I can't factor. But the quadratic expression I can, x and x. The end is negative, so a plus and a minus. Factors of 2, I want a positive 1, so a plus 2 and a minus 1. 2 minus 1 is 1 in the middle. And so canceling out my common factors, I've got an x plus 1 I can cancel out, and an x plus 2 I can cancel out. So on the top, I have x minus 2. And on the bottom, 4 times x minus 1. And number 30, the last one, same kind of thing. I have x squared minus 3x plus 2 divided by x minus, or over x minus 3. I'm dividing, so I'm going to invert and multiply. The 3x minus 9 is going to go on top. And the x squared minus 4 are going to go on the bottom. So factoring that out, the top of that first expression, x and x, the end is positive, so both are the same as the middle, a negative and a negative. Factors of 2 that add up to 3, 2 and 1. Negative 2 and a negative 1 is the negative 3 in the middle. On the bottom, we just have that x minus 3, can't do much with that. Top of the next fraction, my greatest common factor there, I can take a 3 out of there, which leaves me an x minus 3. And the bottom, difference of perfect squares, so x plus 2 and x minus 2 when I factor that one out. So taking out my common factors, I can take out the x minus 3, I can take out the x minus 2. So I have 3 times x minus 1. And on the bottom, x plus 2. And that's the end of homework day 2.